universe keeps its truths behind screens we build without knowing we built them. Modern science did not set out to vindicate the Gnostics. It set out to describe nature accurately, to replace superstition with measurement, to build a picture of reality from observation and mathematics rather than myth and revelation. And yet, the picture that emerged, especially in the 20th and 21st centuries, is one the Gnostics would have recognized immediately. Not in its specifics. They knew nothing of wavefunctions or black hole thermodynamics or the computational limits of neural architectures. But in its shape, its implications, the suggestion that what we perceive is not what is, that the solid world is a kind of illusion, that something stranger lurks beneath the surface of appearances. The Gnostics reached this conclusion through introspection and revelation. Modern physics reached it through accelerators and interferometers. The convergence is either coincidence or evidence. Let's look at the evidence. Start with matter, the thing you can touch, the stuff that pushes back when you push it. The world of chairs and mountains and your own flesh, the undeniable substrate of ordinary experience. Physics took that substrate apart, layer by layer. It asked, what is this made of? And at every layer, the answer pointed deeper. Solids are made of atoms, but atoms are mostly empty space. A nucleus surrounded by an electron cloud, with the distance between them proportional to a football stadium surrounding a marble. So, solids are not solid. They feel solid because of electromagnetic repulsion between electron clouds, not because matter is continuous. Atoms are made of protons, neutrons, electrons. But protons and neutrons are made of quarks, held together by gluons. And electrons? As far as we can tell, electrons are fundamental. But what does that mean? What is an electron at bottom? Here's where the story becomes strange. An electron is not a tiny billiard ball. It is not, in fact, a thing at all in the sense we ordinarily mean. An electron is a mathematical abstraction that sometimes behaves as if it were a particle and sometimes behaves as if it were a wave, depending on how you observe it. This is not a metaphor, this is experimental result. The double-slit experiment has been performed so many times with such precision that it now serves as the standard introduction to quantum weirdness. Fire electrons or photons or any quantum particle at a barrier with two slits. If electrons were simply tiny bullets, you would expect two bands on the detector behind the barrier, one for each slit. Instead, you get an interference pattern, alternating bands of many hits and few hits, the signature of wave interference. So electrons are waves? Not exactly. If you put a detector at one of the slits to see which slit each electron goes through, the interference pattern disappears. You get two bands. The electrons start acting like particles again, but only when you look. Observation changes outcome. The act of measuring, of obtaining information about the system, alters what the system does. Before measurement, the electron exists in a superposition of states, passing through both slits at once, or neither, or some combination that our language doesn't have words for. Measurement collapses the superposition into a definite state. The electron went through the slit, not that one. But what does this mean? Physicists still argue about it. They've been arguing about it for a century. The Copenhagen interpretation says, don't ask what's really happening before measurement. The wave function is a tool for calculating probabilities, not a description of reality. There is no before measurement to ask about. The many worlds interpretation says, the wave function is real and it never collapses. Every measurement splits the universe into branches, one for each possible outcome. You experience only one branch, but all branches exist. Objective collapse theories say, the wave function is real and does collapse, but through some physical mechanism we haven't yet identified, not through the magic of observation. Hidden variable theories say, there are properties we don't know about that determine outcomes. Quantum mechanics is incomplete. Each interpretation is strange in its own way. What they share is an acknowledgement. The simple picture of matter as stuff, existing independently of observation, cannot survive quantum mechanics. Something else is going on. The Gnostics called the phenomenal world an illusion constructed by the demiurge. Quantum mechanics suggests that the phenomenal world is something like a rendering, a display that appears when observation happens, not a pre-existing reality we are passively viewing. The terminology is different, but the structure rhymes. Still, quantum strangeness runs deeper than the measurement problem. In 1935, Einstein, Podolsky and Rosen published a paper intended to show that quantum mechanics was incomplete. They pointed out a disturbing implication of the theory. Two particles that have interacted can become entangled, sharing a quantum state that cannot be described as two separate states. Measure one particle and you instantly affect what will be measured on the other, regardless of distance. Einstein called this spooky action at a distance. He thought it was obviously absurd, proof that quantum mechanics must be missing something. It's not absurd. It is real. John Bell in 1964 showed how to experimentally distinguish between quantum mechanics and any theory with local hidden variables. Any theory where particles have definite properties before measurement and where influences travel no faster than light. The experiments have been done. Quantum mechanics wins. Reality is non-local. What this means is that space is not what we thought it was. We experience space as the medium in which things are separate. You are here, the star is there. Light takes time to travel between. Nothing travels faster than light. Causation respects distance. But entanglement says, not so fast. Two particles can be correlated in ways that don't respect distance. Measuring one instantly affects what you'll find when you measure the other, even if the other is on the far side of the universe. This doesn't let you send information faster than light. The randomness of quantum outcomes prevents that. But it does mean that the two particles are, in some sense, not really separate. Space, which we thought divided things, is underlaid by connections that don't acknowledge division. The Gnostics described the pleroma as undivided, a fullness in which separation doesn't exist. The demiurge's cosmos introduced division, subject and object, here and there, self and other. Entanglement suggests that the division is not absolute. The underlying reality is still connected, And the appearance of separation is exactly that. Appearance. We are looking at the demiurge's world and glimpsing, through quantum experiments, the pleroma leaking through. But quantum weirdness, strange as it is, operates within space-time. Particles are located somewhere. Events happen at some time. The arena may have strange properties, but it's still the arena. What if the arena itself is not fundamental? This is where 21st century physics is pointing. Not just that matter is weird, but that space-time, the background in which everything happens, is itself a higher level phenomenon, emerging from something deeper. In 2013, a physicist named Nima Arkani Hamed and his collaborator Jaroslav Trunka published a paper that sent ripples through theoretical physics. They describe a mathematical object called the amplituhedron. The context? Particle physics uses calculations called scattering amplitudes. When particles collide and interact, these amplitudes tell you the probabilities of various outcomes. Calculating them using standard techniques, or Feynman diagrams, is notoriously difficult. The number of diagrams explodes exponentially for complex interactions. Calculations that should be simple can require supercomputers. The amplituhedron makes these calculations trivial. It is a geometric object, a higher dimensional jewel, in the language of the original press coverage, that encodes the scattering amplitudes directly. Find the volume of the amplituhedron and you've done the calculation. But here's the strange part. The amplituhedron works without spacetime. The standard Feynman approach calculates interactions by summing over all possible paths particles could take through space and time. The amplituhedron gets the same answers without any reference to space or time. It treats locality, things happening at specific locations, and unitarity, probabilities summing to 1, as emergent, as features that appear in the results, not assumptions baked into the method. This suggests that spacetime is not fundamental. It is what you get when you look at the deeper structure from a certain angle. The amplituhedron exists in a more abstract mathematical space, and our familiar spacetime is a projection, a shadow, a particular way of viewing the underlying geometry. The implications are vertigo-inducing. If space-time is emergent, then the arena in which the demiurge's physics operates is itself constructed. Not the basement, not the ground floor. A level of the building, perhaps a high level, with deeper structures beneath. The Gnostics didn't know about amplituhedrons, but they knew this. The cosmos as we perceive it is not the true reality. It is a creation, a making, a building. What is truly real lies behind or beneath or beyond the constructed world. Arkani Hamed, in interviews, uses almost mystical language. Space-time is doomed, he says. Locality is not a fundamental principle. He is not a Gnostic. He's a physicist at the Institute for Advanced Study, working within the most rigorous traditions of theoretical physics. But the conclusions he's reaching would not surprise the authors of the Nag Hammadi texts. Another line of evidence points the same direction. In the 1970s, physicists working on black holes discovered something puzzling. Black holes have entropy, a measure of disorder. of the number of ways the interior could be arranged, but the entropy of a black hole is proportional to its surface area, not its volume. This is weird. Ordinarily, entropy scales with volume. A box twice as big can contain twice as many states. So it has twice the entropy. But black holes don't work that way. All the information about what's inside seems to be encoded on the surface. In 1997, Juan Maldacena proposed a radical conjecture that would become one of the most important results in theoretical physics: the ADS-CFT correspondence. It says that a theory of quantum gravity in a certain kind of spacetime, a anti-de Sitter space, is mathematically equivalent to a theory without gravity on the boundary of that spacetime. The bulk, the interior, is a hologram. The boundary is the film. This is not a metaphor, it's a mathematical duality. Calculations done in the bulk give the same answers as calculations done on the boundary. The three-dimensional interior plus time and the two-dimensional boundary plus time are different descriptions of the same physics. What does this mean for our reality? Our universe is not anti-de Sitter space. Anti-de Sitter has a negative cosmological constant. Ours is positive. So Maldacena's original correspondence doesn't apply directly. But the holographic principle, the idea that the information in a volume can be encoded on a lower dimensional boundary, appears to be a general feature of quantum gravity, not just a quirk of one particular spacetime. If our cosmos is holographic, then the three-dimensional space we navigate is a projection. The real information is encoded on a two-dimensional surface. Perhaps at cosmological scales, at the boundary of the observable universe, or perhaps at the Planck scale, at the finest grain of spacetime itself. We live in a projection. The Gnostics said, the world is not ultimate reality, it's a construction, an emanation, a lower-level phenomenon derived from something higher. The holographic principle says, the world may be literally a lower dimensional projection of higher dimensional information. The language differs, but the structure aligns. David Deutsch, the physicist who pioneered quantum computation, has developed another framework that points toward emergent spacetime: constructor theory. Standard physics asks, what happens? Given initial conditions and laws, what are the outcomes? Deutsch inverts the question: what transformations are possible and what are impossible? A constructor is anything that can cause a transformation to happen while retaining the ability to cause it again. A catalyst is a constructor. It enables a chemical reaction without being consumed. A computer is a constructor because it can perform computations repeatedly. Life itself is a constructor. Organisms reproduce, causing their own continuation. Constructor theory reformulates physics in terms of which transformations are possible and which are forbidden, rather than which trajectories particles follow. Spacetime, in this view, is not the fundamental stage on which physics happens. It emerges from the structure of possible transformations. Deutsch argues that this approach can unify quantum mechanics and general relativity, the great unsolved problem in physics. If he's right, and this remains speculative, then spacetime, matter, and energy are all secondary. The fundamental thing is the space of possible transformations. What can happen, what can't, and why. This is a profoundly abstract view of reality. The world as we experience it, the spatial and the temporal world, the world of objects and forces, becomes a particular rendering of deeper logical structure. The substrate is not stuff. The substrate is information about possibility. The Gnostics, if told this, might say yes, exactly. The demiurge works with the materials he has, but the materials are themselves derived from something prior. The cosmos is a making, a construction from building blocks that are not physical, in the sense the cosmos is physical. We've been discussing physics, the nature of reality independent of observers. Now consider the observers themselves. If space-time is emergent and the material world is a rendering, what is doing the perceiving? And can we trust perception to show us what's really there? Donald Hoffman, a cognitive scientist at UC Irvine, argues, no, we cannot. And he has mathematical proofs to support it. Hoffman's argument begins with evolution. We are products of natural selection. Our perceptual systems were not designed to show us truth. They were shaped by competition, by the relentless logic of reproductive success. Organisms that perceived in ways that helped them survive and reproduce left more offspring. Those offspring inherited the perceptual systems that promoted survival. The question is, does accurate perception promote survival? Hoffman and his colleagues ran evolutionary simulations. Mathematical models of populations competing for resources where perception was allowed to evolve. They tested organisms with different perceptual strategies. Veridical perceivers see reality as it is. Fitness-oriented perceivers see reality transformed to highlight survival-relevant features. Interface perceivers see a simplified representation that has no resemblance to underlying reality, only predictive utility. And the results were stark. Veridical perceivers went extinct. Fitness-oriented perceivers did better. But interface perceivers dominated. The simulations show that evolution drives perception toward useful fiction, not accurate representation. A desktop interface doesn't show you the computer's actual operations. Transistors switching, electrons moving, voltages fluctuating. It shows you icons that help you interact with the computer without understanding its innards. Hoffman argues our perception is the same, a user interface that has nothing to do with what's actually there. And this is not obvious. We assume vision shows us the world. We see a rock, we pick it up, gravity pulls it down when we drop it. This feels like direct contact with reality. But the feeling is the interface. The experience is the desktop. We cannot see past the icons to the underlying computational structure. Hoffman calls this interface theory of perception. We don't experience reality. We experience a species-specific interface shaped by selection to hide reality's complexity and display only what we need for survival. But if perception is an interface, what's behind it? What is the reality that our icons represent? Hoffman makes a radical proposal. Consciousness. Not matter, not space-time, not fields or particles or wave functions. Consciousness all the way down. His mathematical framework, called conscious agents, models reality as a network of interacting conscious entities. Each agent has experiences, makes decisions, interacts with other agents. The interactions generate what we perceive as space-time and matter, but these are emergent from consciousness, not the other way around. This is idealism, the philosophical position that mind is fundamental and matter is derived, but given mathematical formulation. Hoffman has shown that networks of conscious agents can reproduce the mathematical structure of quantum mechanics. The wavefunction in this view is not a physical object but a representation of conscious agent dynamics. The proposal is speculative, it's not established physics, and many scientists find it absurd. Consciousness causing matter, rather than the reverse, seems to invert everything we've learned. But consider, we don't actually know that matter causes consciousness. We assume it because correlations exist between brain states and mental states. But correlation is not causation. The hard problem of consciousness, why any physical process should produce subjective experience, remains unsolved precisely because we cannot show how matter generates mind. We can show correspondence, but we cannot show mechanism. If Hoffman is right, the puzzle dissolves. Consciousness doesn't come from matter, matter comes from consciousness. And the hard problem was hard because we were asking the question backwards. The Gnostics would recognize this move. They insisted that the divine spark, the pneuma, was not produced by matter. It preceded matter. It got trapped in matter. The demiurge built the material cosmos, but the consciousness experiencing it came from somewhere else, from the pleroma. Hoffman's conscious agents resemble the pleroma more than they resemble the demiurge's world. An infinite network of experiencing entities, interacting, generating the appearance of space-time as a byproduct of their dynamics. The material world as a desktop. Consciousness as the computer running beneath. Now, let's step back and survey what we've covered. Quantum mechanics shows that matter is not what it seems. Particles exist in superpositions until observed. Observation affects outcome. Entanglement reveals non-local correlations that suggest space is not fundamentally divisive. And theoretical physics suggests that spacetime is emergent. The amplituhedron calculates scattering amplitudes without assuming locality or unitarity. The holographic principle encodes three-dimensional information on two-dimensional boundaries. Constructor theory treats spacetime as secondary to the structure of possible transformations. Cognitive science, at least in Hoffman's version, suggests that perception is not veridical. Evolution shaped our senses to survive, not to see truth. The world we perceive is an interface, a rendering, a user-friendly display that has no necessary resemblance to underlying reality. None of this proves the Gnostic worldview. Proof is not available. What is available is resonance, a pattern of rhyming between ancient intuition and contemporary discovery. The Gnostics said, the world is not ultimate reality, and physics now has multiple frameworks suggesting the world as we perceive it is emergent, constructed, lower dimensional, and interface mediated. The Gnostics said the true divine is hidden behind a veil, and physics now has the holographic principle, suggesting that the information is encoded elsewhere and we experience a projection. The Gnostics said something in us knows that this is not the deepest level. Consciousness research now has no explanation for how matter produces experience, which is exactly what you'd expect if experience is fundamental and matter is derived. I am not arguing that the Gnostics were doing physics. They were doing something else: phenomenology, theology, myth-making, and introspection. Their methods were different. Their vocabulary was different. But they were pointing at something, and what they were pointing at is starting to come into focus through our most rigorous methods of investigation. The question is not whether to believe the Gnostic myth. The question is whether to notice the convergence, whether to entertain the hypothesis that these very different approaches, separation by 2000 years, separation by method and separation by culture, are triangulating on the same underlying reality. If they are, the implications are enormous. The world is not the ground floor. The creator of the world, whether demiurge or evolution or simulation programmer, is not the ultimate source. Something in us, call it spark, call it consciousness, call it the hard problem, does not fit the architecture. And knowledge, deep, experiential, gnosis-level knowledge, might be the way through. We have now examined two perspectives on the prism: the ancient Gnostic diagnosis in our last video, and the modern physics of suspicion in this one. They converge more than they should if the Gnostics were merely projecting psychological distress onto the cosmos. But there's another source of evidence, stranger and more direct, but even so, more disturbing. Something is demonstrating physics we don't possess. Something is appearing in our skies, on our sensors, in our most credible institutions' classified files. The phenomenon